Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, we're going to start with chapter 18, limits and derivatives. So let's start. As the beginning, let me give you a basic explanation about what is the meaning of limit. Limits mean that you are trying to evaluate the function when x approaches a value. For example, here, this is the x-axis, and this is the y-axis. Here you have a hole, and of course, at this hole, the function doesn't have any value. So I'm trying to approach this hole from right and left. So I'm trying to approach the function when x approaches 2. So x approaches 2 from right and left. So let's go from right here. Now, if I approaches it, it would approach 4. So the answer when it approaches from right, it give you 4. And if also your approach is from left, it give you false. The same, it give you 4. So pure limit from right equals to the limit from left. This means that your limit exists and it has a value. So it's equal 4. Now let's take another example here. I'm taking the limit when x approaches a. Here is a. From left and right. So let's approaches from right. Let's go to the y-axis. A at this one, it give you 1.3. And from left, as you see here, it give you 3.8. So this means that the limit from left does not equal the limit from right. So this means your limit does not exist. So there's a condition here. So for the limit to be exact, that the limit from right equal to the limit from left. We already learned how to solve limits graphically. Let's go to solve it algebraically. Now, when I'm asking you to get the limits, the first step that you have to do is the direct substitution. Let me give you an example to understand this. So, for example, if I'm asking you about the limit of x plus 2 when x approaches 1. So the first step is a direct substitution, which means I have just to plug, and instead of x, I'm gonna put 1. So 1 plus 2 equal 3. So the answer is 3. Sometimes you have, after you substitute, you got something like 0 over 0 or infinity over infinity. We call this indeterminate form. So once you have this, you have to manipulate or do algebraic manipulation or to use some rules that we're gonna learn it now. So if you have 0 over 0, this means that you have maybe to factorize or to multiply by the conjugate or to use the derivative or the L'Hopital rule. So we're going through all of this now. Question number 1 is asking you about the limit when x approaches 2 for 3x plus 5. So the first step, I have to substitute. So 3 times 2 plus 5 give me 11. Now here's asking you about the limit of the function of x when x approaches negative 2. So let's see here. Here's x negative 2. So I have to examine the limit from left and right. Here's the right and here's the left. All you have to do is just walk on the curve or on the graph. Here I reach it 2. Now go for the y-axis. It's 2 from right. Now let's go from left. Here, still, I will go for the y-axis, still 2. So this means that the answer is 2. Now, if function of x, this is kind of piece function, this means that you have the function and like parts. So here, I'm trying to examine the function or the limit of the function of x when x approaches 1. So this means I have to substitute also here. So 2 times 1 plus 1 give me 3. And 1 power 2 minus 1 give me 0. So the limit is just like, here's the 1, and you have the right for it and the left for it. On the right side, which is the greater than or equal 1, it's equal to 0. And on the left side, it's 3. So this means that your limit does not exist, because the limit from right does not equal the limit from left. Now he's asking you about the limit when x approaches 4 for this expression. So let's see here. Let's try the direct substitution. So I will just put 4 instead of the x. So 4 plus 5 is 9. What is the square root of 9 is 3. 3 minus 3 is 0. And 4 minus 4 is 0. So this is 0 over 0. Indeterminate form. So this means I have to go for the manipulation, which means I have to factorize or to multiply by the conjugate or use the derivative or the logarithm rule. So here I have radical or roots. Once you have radical or roots, this means that you have to use the conjugate. What is the meaning of conjugate? Conjugate means that the same numbers but with different operation between them. So here I'm gonna multiply up and down by the conjugate. So here's my original expression, right? Now I'm gonna multiply by the conjugate. What is the conjugate? The same numbers but with different operation between them. Here is negative, and here I put it positive. Now, when you are dealing or multiply by conjugate, just like you are applying the difference between two squares. Here, let's multiply. Now, root x plus 5 squared. This means you're going to cancel the radical, so it would be x plus 5. And negative 3 squared is minus, and 3 squared is 9. Here, it would be x minus 4 multiplied by root x plus 5 plus 3. So x plus 5 minus 9, x plus 5 minus 9 give me x minus 4. So I could just erase this one and write x minus 4. So I could cancel it. So it would give me the same expression here, 1 over root x plus 5 plus 3. Now I'm going to substitute again. So here's x approaches 4. So 1 over 4 plus 5 give me 9. What is the square root of 9 is 3. So 3 plus 3 give me 1 over 6. So let me again remind you how to solve these kind of questions. Again, for example, if you have x plus 4, the square root of x plus 4, minus 3, multiplied by x plus 4, square root of x plus 4 plus 3. How are you going to solve it? You just multiply this part by this part and this part by this part. So here, and of course, when you multiply in radical, they're going to cancel each other here, x plus 4. Now, and you have the negative sign in the middle, keep it. 3 times 3 give you 9. So the answer by the end would be x plus 4 minus 9 give you negative 5. Just like to remind you how to solve this kind of questions. Now, if function of 2 equals 6 and the limit of function of x when x approaches 2 from left equal 4, and limit of function of x when x approaches 2 from right equals negative 2. What is the limit of the function of x when x approaches 2? Okay, it's clearly obvious here that the limit from right does not equal the limit from right. So this means that your limit does not exist. Here's the left and here is the right. Question number 6, the value of limit of this expression when x approaches 0. So again, here I'm gonna just substitute. So 3 to the power of 0 minus cosine 0 plus 4 times 0 minus 1. So let's see here. 3 power 0 and the same power 0 give you 1. Cosine 0, it's 1. And 4 times 0, it's 0. And you have negative 1 here. So 1 minus 1 is 0. 0 plus 0 is 0. 0 minus 1 give you negative 1. So the answer is negative 1. Now question number 7, the limit of this expression when x approaches 3. First step, direct substitution. So let's substitute. So 3 power 2 minus 9 over 3 minus 3. 3 power 2 equal 9. 9 minus 9 over 3 minus 3. So it's 0 over 0. Now this is indeterminate form. So this means maybe I have to factorize. Maybe I have to multiply as a conjugate or use the L'Hopital rule or the derivative. Okay, I'm gonna solve it with two ways here just for your understanding. So let's start. We don't have here any radicals, so this means maybe I have to solve it with factorization or using the derivative. But since I didn't explain the derivative, I'll just explain it in a rough way, then we're gonna complete. So here, I'm gonna factorize. Of course, this is a difference between two squares. And difference between two squares, this means that you just have to take the square root for both sides and two brackets, one of them negative and one of them is positive. So here, square root of x, it's x. Square root of x power 2 is x, and square root of 9 is 3. So I canceled x minus 3 with x minus 3. I left with x plus 3. So let me substitute again. So after you factorize and you're going to cancel one of these, you have to substitute again. So here, 3 plus 3 give me 6. Now, course in grade 12, you already took the derivative, so I just assume that you take it. So let me try to solve it while taking the derivative. Now let's take the derivative of the numerator. It would be 2x, and the derivative for 9, it would be 0. Here, what is the derivative of x? It's just 1. Now let's substitute. So instead of x, I'm gonna put 3. So 2 times 3 give me 6, and 6 over 1 give me 6. So the answer is 6 again. So you have two ways to use the factorization or to take the derivative for the numerator and the denominator, then you substitute again. Now let's take the limit when x approaches 2 for this expression. So here I don't have any radical, so I will not multiply by conjugate, but I could use the factorization or taking the derivative. I will solve it by both ways. Here, let's factorize. I need two brackets. Here's the last term is negative, so this means that you have two brackets, one of them positive and one of them is negative. And you're searching for two numbers. If you multiply them, it give you 10, and if you subtract them, give you 3. So the option here is just 5 times 2. So which one will take the positive sign? The greatest number, because the middle term is positive. So here's 5 and here's 2. And let's factorize this one. This is a difference between two squares again. Two brackets, one of them negative, one of them is positive, and you just take the square root for each term. What is the square root of x power 2 is x, the square root of 4 is 2. Now let's cancel. I left with x plus 5 over x plus 2, and I will just substitute again. So 2 plus 5 is 7, and 2 plus 2 is 4, so 7 over 4. Let me solve it with derivatives. So I'm going to take the derivative for the numerator and the denominator. If I took the derivative here, this would be 2x plus 3, and this would be 2x. Now let's substitute. X instead of x, it would be 2. 2 times 2, 4. 4 plus 3 is 7, and 2 times 2 is 4. Of course, solving it by derivative is very easy way. Okay, let's take the limit here. X approaches 0. And you have a radical. So this means that you have to multiply by the conjugate. Again, conjugate means same numbers by different operation in the middle. So here, here is the conjugate up and down. Good. Now, let's multiply. Again, while multiplying, you just multiply the term here with this term and this term with this term, and you keep the negative sign in the middle. So the radicals, they canceled each other, so it would be 5 minus x. And here again, they cancel, so it would be 5 over x multiplied by the square root of 5 minus x plus square root of 5. Now, 5 minus 5 cancels 0. Negative x with x canceled, so I left with negative 1 over square root of 5 minus x plus root 5. Now, let's substitute. After you cancel, you have to substitute again. The x is 0, so square root of 5 plus square root of 5 give me negative 1 over 2 square root of 5. Now, I don't have this one in the choices. Now, remember, when you're dealing with radical, it's favorable to rationalize the denominator. What is the meaning of rationalizing the denominator? Is that you make the denominator as integers, as a whole number. Doesn't have any radical. So this means I have to multiply by the radical up and down. So here, the radical here is root 5. So I'm going to multiply it by root 5 up and down. So here it would be root 5, negative root 5. And the root 5 times root 5 give you 5. So 2 times 5 give you 10. So negative root 5 over 10. Okay, I already covered how you got the limit when x approaches a number. Now let's take how we got the limit when x approaches infinity, positive or negative infinity. When x approaches positive or negative infinity, of course, the first step, the direct substitution. So let me give you an example here. So the first step, direct substitution, I'm gonna substitute. So it would be infinity plus 3. Give me infinity. Anything positive or negative infinity give you infinity. Okay, good. What if I have something like this? If I substitute, it give me infinity over infinity in determinate form. So this means I have to manipulate. Now, we have a rule, we call it L'Hopital rule, and just like specific for is the rational function. Rational function means that you have a numerator and denominator. So we have 3 cases. Depend on the degree or the power of numerator and the denominator. So let me give you the 3 cases here. Sometimes you have the numerator and denominator are equal in the power, or sometimes it's greater, or sometimes it's smaller. So let's take an example. Take the limit of x when x approaches infinity for x power 2 plus 3 over 2x power 2 plus 5. Now let's see here. The first step, you're just gonna neglect anything rather than the variables. Here's the variables. So it would be x power 2 over 2x power 2. Now, let's check the power for numerator and denominator. Here's the second degree and also the denominator in the second degree. So you're going to just like take the coefficient or the numbers besides the variable or the x. Here you don't have any number, right? So I'm just if you have the variable without any number, so you just put 1. So the answer here is 1 over 2. So the limit when x approaches infinity for this expression, it's just only 1 over 2. Now, let's take another example. If you have the numerator smaller than the denominator. Again, we're just neglecting everything, we just take the variables. So let's take the variables here. It would be x power 2 over x power 3. Now the numerator power smaller than the denominator power. So all the time the answer would be 0. Because if you substitute it, it would be 1 over infinity. And 1 over infinity all the time equal to 0. Okay, so once you have the numerator degree smaller than the denominator degree, this means that the answer all the time would be 0. Now, let's take another example with the numerator greater than the denominator. Here, we take the limit when x approaches infinity for x power 3 plus 3 over x power 2 plus 4, for example. If you substitute, you got here again, it would be here x power 3 over x power 2. So if you cancel or simplify, you're going to just x. Now substitute the x, it gives you infinity. So if you found that the numerator degree greater than the denominator degree, so the answer all the time would be infinity. So 3 cases. Numerator small equal to the denominator degree. This means you're just gonna take the coefficient of x. Numerator smaller than the denominator, the answer all the time would be 0. Numerator greater than the denominator degree would be infinity. Now let's try to solve. Here I have the limit when x approaches infinity. The first step, I'm gonna check the degree of numerator and degree of denominator. So it would just be here 5x over 3x from the first degree. So I'm just gonna take the coefficient. So it's 5 over 3. Okay, here it's x power 2 over x. The numerator greater than the denominator, so it would be infinity. Okay, here he's telling you take the limit when x approaches infinity. Bx over 4 plus the absolute value of x equals 3. What is the value of b? Okay. He already gave you the limit. And we agree that if we have a rational function, we just take the coefficient of x. So it would be like this. Bx over the absolute value of x. Now, he said here that it's x approaches infinity. Remember that absolute value means that you have positive infinity or negative infinity, but since we are just approaches infinity, I'm gonna take the positive infinity. Okay, so it would be here px over just x, which means it's 1 here, the coefficient. And he told me that the limit equals 3. So this means b should be, so b over 1 equals 3. This means that b equal 3. Now the limit of infinite sequence, whose general term is, we're just dealing with the infinite sequence as we're taking the limit for infinity for any rational function here. So again, I'll just exclude anything rather than the variable. So it's 4n over 2n. The same degree. So I'm just going to take the coefficient. So it's 4 over 2 equals 2. Now we're just discussing the last topic in limits, which is the function continuity and discontinuity. How could I tell if the function is continuous or it's not continuous or discontinuous? If I'm drawing a graph and my hands, I cannot lift my hands while I'm drawing it. For example, while drawing the quadratic function, we're just drawing it smoothly. But for this one here, for example, if you're drawing this, you're just gonna draw this part of the curve, and then you're gonna lift your hand and draw this part. So you have here a discontinuity. But let's take it here in a theoretical part. It's discontinuous when the limit from left does not equal to the limit from right. It's the same here. Let's see here. For example, when x approaches a, I'm gonna examine the limit from left and right. Here, from left, it's going for positive infinity. And from right, it's going for negative infinity. So I have here infinite discontinuity. Here, for example, in the jump discontinuity, you have this graph at x approaches a. Let's see. At x approaches a from right and left. Let's see. From right, here's from right. And here's from left. Different values. So this is a jump discontinuity. Also here you have a removable discontinuity, and we express it as a whole of the graph. But let me give you an algebraic expression explaining this. It happens when you are canceling a bracket from the numerator and denominator. Let me give you an example. X power 2 minus 4 over x minus 2. If I factorize this one, it gives me x minus 2 times x plus 2 over x minus 2. Now, if you're going to cancel, x minus 2 and x minus 2, and left with x plus 2. Now, when you cancel x minus 2 and x minus 2 here, this is the whole. So we call this removable discontinuity or whole. Okay, here finds a value of k such that the function is continuous at x equal 1. So continuous means that you have the limit from right equals to the limit from left, and it's equal to the function itself when you evaluate it. So let's try. So I'm going to substitute here the 1. 2 times 1 per 2 plus 7, it gives me 9. So this means this part should be equal to 9 when I put the x 1. So k times 1 minus 1 give me 9. So k minus 1 give me 9. Transpose, so it will be k equal 10. Identify the type of discontinuity of the function shown in the graph. Here I have, let's examine the function. Here is it from left and right. Here is going for positive infinity, and here is going for negative infinity. So it's infinite discontinuity. Identify the type of discontinuity in the first function. Here, he's telling you there's a function of x equal x power 2 when x does not equal 2, and it's 5 when x equals 2. Now, it's sometimes equal to and sometimes does not equal to. This means that you have a whole open circle and a closed circle. So this means it's a removable discontinuity. What type of discontinuity does the graph show at x equals 3? Here's the 3. Let's examine it from left and right. Here's right. If I examine it from right, it's equal 4. If I examine it from left, it's equal to 2. So this means this is a jump discontinuity, a jump from 2 to 4.